So, hi everyone. So this is Surinder, working as school assistant physical science in JPHS Pusala. So I am participating in the science fair. I am going to take my topic on interactive innovations in science, bridging with ICT to laboratory. So laboratory and ICT, how it helps to the students, teachers. So I will explain in detail. Thank you. A beautiful experiment. Suppose you want to lift the pen up to here. You want to make it to move the pen without using your hand. So now with this experiment you can say the motion of the object, the circular motion can be explained, and you can explain the force, we can explain the concept of centripetal force, centripetal acceleration. So how, suppose if you should not pull it, what I will do, just I will make using. So what happened here, it is a motion of the stone is here, circular path, and moreover because of centripetal force it has been lifted. The pen is lifted from bottom to top. With this simple experiment we can make it multiple benefits, multiple concepts. So now is what we have taken, just we have taken 2 screws, 1 rubber band, 2-3 rubber bands. What I have taken, I twisted the pencil. Now observe here the motion of the pencil here. So now it is making around a fixed point, it is making circular path. So with this simple experiment we can see, show the circular path of the body. Okay, so how physics is interrelated to different topics we will see. So now just I have taken a stone, trying to fix the taken a fixed support to the one other end of the wire, hung some stone, small stone. So now this is at rest position. Now what I am doing, now you are going to observe, suppose if I pull this distance and lead, so it is in the motion. So to a fixed point, so it is taking a oscillatory motion. So the to and fro motion of the object around a fixed path is called oscillatory motion. Now here how it is important. Now from suppose let us say I am leaving from A point reaching B and A. So when it reaches to A, this is called one oscillation. The time taken is called time period. Suppose this is the length of the pendulum, let us say, or thread. Now what I will do, observe here, just with the same experiment, I will make it off. So how the time period and how is the frequency will see. Just I am pulling into the same extreme point, leaving. Now you can see that within the same time it is making more oscillations. So time period is less, frequency is more. Now still if I decrease the height, length, let us see. So it is making more oscillations. So the meaning is, the shorter the length of the pendulum, the time period is less, frequency is more. So with this concept we can say, we can relate the time period and frequency easily. Children will have a problem with concave shape and convex shape. So in our home, just simple, the broken bangle can be used for understanding the concave shape and convex shape. Suppose when you look at, this is curved inward. So when the light falls on the curved inward, that reflects and meet at a point, it will form a real image. So this is called curved shape and it is called concave shape. Now just the bulged outside, this path will be a convex shape. So with this simple broken bangle, we can understand concave shape and convex shape. So now the same thing can be observed here. It is a concave mirror. It forms real images. So dentists use concave mirror. So now if you place an object at the focus of the mirror, we observe the virtual image, magnified one. So that is why between the pole and focus, if you place the object, then we can understand the virtual image concept. virtual image, and moreover the magnified image can be seen here. So now we have another mirror called convex mirror. You see here the bulged outside. So the reflecting surface will be bulged outside and it forms virtual image, and moreover when the light incident on the mirror, it diverges the rays, it converges the rays. So it forms real image, it forms virtual image. Okay. Right here. So in the optics topic, so light is a property: reflection, refraction, interference, diffraction. Now, so suppose we are able to see the object, the board, through this one. So that is why you can say transparent substance. Now, when you observe, here is a glass medium, here is a water. Now the light is transferring from water to air or air to water and through the glass also. Now to understand the diffraction, let us see if I place the pen here. Now just you observe at the interface, here is the interface, we can say the interface term. So the separation of the medium is called interface. Now if we observe from this one, there is a bending of the pen is observed. So the bending is observed from here. You see here. From this place, the straight line is now cut into another line. So what is the reason? This is because of refraction. Now whenever you are viewing the pen here, the meaning is light is transferring from water to air. So it is a denser, air is a rarer medium. When it is coming out, it goes away from the normal. So that is why, so when it is moving in this direction, if you take the path of the light, it will come in this direction. That is why there is a bending is observed. Now similarly in the shops, we used to observe the lemons. Here, this is a cap. Observe the size of the cap here. Now, if I place in the water, now we can see the bulginess of the water cap. You see here. So at the two ends of the cap, the light ray emitted far away from the normal. So that is why we observe the bulginess of the cap, similar to the lemon. Now you can observe from the interface here, the top portion, the depth which is kept inside. So this is because of refraction. So here already we know the properties of light. Refraction is one of the properties. Now if you observe this weight, now you feel that the letters on the top of the glass slab, but actually there, if you observe inside, the letters at the above this surface, almost all bottom. But because of the thickness and because of the refraction, the letters inside appear to raise to height. So the letters are very close to this surface. That is because of refraction. So this is observed in our principal room, headmaster rooms. The papers below the glass sheet appear to be raised to height. Right, here we know the tuning forks. So tuning forks, so these are the forks having some threshold to hold it, and if I apply certain force, it will get into vibration. Now here, from this simple tuning fork, we can know the frequency concept. It is 420, so 420 Hz. It is 480 Hz, and moreover from this experiment we can know the sound is different from different frequency objects. Suppose if I apply force here, now you are getting, we can listen different sound. 480 Hz, so we will get different sound. Similarly, in the nature, in the surroundings, different objects, if it will give different sound. It will give different sound. It will give different sound. It will give different sound, because so here is air is present, here is water is present. So depend on the substance constraint, the sound will be varied. Okay.
Go.
Right here, so we have beautiful experiment and multiple benefit experiment. Suppose simple LED concept, so we'll give different concepts. Already LED nothing but light emitting diode, so which has a positive terminal and negative terminal. So it is a PN junction diode. So here, which is the positive? We have longer lead, shorter one. Now, what I have done? All the LEDs, I have taken 3 LEDs. I have joined all the positive one side, all the negative terminals one side. This is called parallel connection. Now, if I connect negative terminal of the LED to another positive terminal, so this is called series connection of the LEDs. So now, in the school level, with this experiment, we can show the conductivity property, we can show the series connection of the bulbs, we can understand the connection of battery and LEDs, everything. So now, let us see. First, I will connect in the series connection. So today, I will perform series connection of the bulbs. So now, this is series connection of the bulbs, where in functions generally we usually observe. So now we can understand the intensity concept, current, electric current concept through the bulbs, and based on the intensity, how it is. If we remove one bulb, it does not glow. We don't observe another bulb will glow, and the current is constant through the both LEDs. Now, suppose here already we know parallel connection. So now what I am doing, just I will connect, already we know we have to make it forward bias. So I will do in this way, negative to negative, positive to positive. Now here, in the parallel connection, what happened? The current is divided. The current is divided, and depends on the resistance, the current will flow. So now, the same experiment can be useful for conductivity property of metals. Suppose, generally if I take a chalk piece is a conductor or not. So for that one, just you act like a switch. So keep here 2 ends, so the bulb is not glowing, so it is a bad conductor. Suppose, we know the pen, so it's a plastic, it's a bad conductor. So with the same experiment, conductivity can be observed. Suppose the same pencil, let us see. So I have taken sharpened 2 ends. Now you see here. So pencil is nothing but already we know the graphite. So graphite is a good conductor. So now you see here. So when we insert, when we fill the gap between 2 wires with graphite or pencil, it will glow. So now the graphite is a good conductor from this experiment we can see. Now let us see if I place the layer of the pencil. Now here it is acting like a bad conductor. So that is why it is acting like insulator, whereas the graphite is a conductor. Now, so we know the Newton's first law, second law and third law. Newton's third law applications in our daily life we can observe so many. To understand the Newton's third law, the action is equal and opposite to the reaction. So for that purpose I have blown the air into the balloon. So I made it to understand the air comes out, whether the vehicle or the trolley will move in this direction or not, we will check. So till now what happened? The air entered into the balloon, so that is inside the air that is pushing the balloon, the surface of the balloon in all the directions. When I leave the air and I leave this space, air comes out. So immediately the amount of force which is coming out, in this direction on the surface of another one, where the net force is not zero, in that direction that is moving. Similarly, while we are walking, while we are swimming, the birds flying, when we kite flying in the sky, kites. So there are so many applications. Rocket example. So all are the example of Newton's third law of motion. Okay. So here already we know the importance of Newton's laws of motion. So there are so many applications. So let us see first. So I have taken a coin on the paper. Suppose we know the force concept. Suppose if I pull the coin, so the force acting along with the force acting on the paper as well as on the coin. So that is why it is moving. So now to understand the Newton's first law, until the force acted on the body does not change its state. So here what I am doing, I am pulling the fast. So now only the paper comes out. The meaning is the force is acted on the paper but not this one. So until the force acted on the coin, it is not changing its position. This is inertia concept and moreover first law of motion. So we all know the ring magnet here. Now suppose here we have the device called compass. So compass also consists of a tiny, very thin magnet only. It is used for showing the direction north and south. Now to understand this concept, the magnetic field concept and magnetic force, magnetic induction. Here you see, so this is a magnet. So when it is away from the magnetic needle, there is no deflection. Now if I bring near here, what happened here, you can understand that you see here the needle is affected by this ring magnet. The meaning is this magnet is applying force on the needle. So that is called magnetic induction. Now the region surrounding to where the effect of magnet is there is called magnetic field. So now if I move away, the number of lines are decreased, magnetic force is decreased. So there is no deviation or deflection. Now with this experiment we can know the magnetic field concept, magnetic field strength, the number of magnetic lines, and moreover when you are going away from the needle, there is no effect. The meaning is magnetic field is restricted to a particular area. Now in the physics, similar to the magnet, we have Oersted experiment. Now you see here, these are with this experiment we can know the series connection of the cells. We know the compass. What is a metal we can know. This is called Oersted experiment. So in the electromagnetism experiment, now what I am doing, I have connected two ends of the wires here, and now instead of magnet, this wire also can act like a magnet. The current carrying conductor acts like a magnet is given by Oersted. So now we can see here. Now before the connecting or making closed circuit, here there is a deflection is observed here. So the deflection is because of the wire is also acting like a magnet, or it generating magnetic field. So the current carrying conductor acts like a magnet. Right here. So now generally we have another beautiful experiment to understand the concept of air pressure. So everyone feel that this is empty, nothing is there. But to check air is present, we have a beautiful experiment. Just to have taken in a can in tin water, and just what you do, we have to make it invert and immerse in the water. Please come. Immerse in the water here. So now what happened, I feel some pressure because air is not making me to move inward. It is applying force on the water. So that is creating pressure. So now we can see that we will get a clarity. No water molecule is present here. So now the meaning is nothing is entered, no water is entered inside because of the air pressure acting on the water. Now similarly we can understand the buoyant forces. Just inside the bottle also air is present. So just I push in the downward direction. What happened? The amount of force acting in the downward will be applied in the upward direction. That is why it is moving up. It is we can say reactive. So reaction occurred because of the action in the downward, we can say. So the air is inside the air, that is applying or creating pressure on the water. So simulations. So simulations give real laboratory feeling, and moreover we can change the variable as we wish, so without having any difficulty. So PhET is one of the simulations. So we can simulate and we can change the variables and we can select the topic. So here, so without, now you can understand this concept very easily. If I move the image, if I move the object, how the image we can see. If I change the position, so everything can be seen. Practically it may not be possible. So this is from PhET. We have so many simulations. So another interactive simulations platform is ophysics. So here we can change the size of the object, so we can understand the image and we can change the position and we can change the position of the object, so then we can understand easily the nature of the image. Suppose if I make the object below the principal axis, in practically it is not possible, but we can show easily with the help of simulation. So there are n number of simulations to understand, so which helps in teaching and learning process.